Okay, so this is our last bit on this one. We have a little bit of thought again, trying to keep you engaged again, and then we've got a few dilution problems, and then we're done. So go ahead and pause. Try to fill them in yourself first. Okay, so the need to use a concentrated solution to prepare a more dilute solution is very common in chemistry lab. Many reagents are sold in certain concentrations, and we need to dilute them to get to the concentration we need. You guys have seen this even in stores. You know, you can like buy laundry detergent that's like 4 times concentrated, 10 times concentrated, because it's easier to ship because you don't have the volume and you can get it at, like, it's more discounted. A lot of times it's more discounted. Same thing with chemistry. You know, they'll send us concentrated things and you don't want to work with it as concentrated, so you just add your own water and you're good to go. We do that in the lab for the Gen Chem folks. Okay, so the dilution is the process of adding solvent, I should be crossing these out, solvent, dilute, solution, usually water in Gen Chem 1, 2, and that would be decrease the concentration of the solution, because whenever you add water, you're decreasing concentration. You make it more dilute. And as a reminder, moles over volume. Increasing solvent means you're increasing the denominator, which reduces the concentration of the solution. Again, yours, I'm going to double check, make sure all your words are correct. The number of moles of solute in the solution. What happens to those? So we've got something, we got a container of something, we got our solute in there, and then we got some liquid. So here's our liquid. So let's say I want to like fill the liquid all the way to the very top. I'm just adding liquid. I'm not adding anything to those dots. Those dots are still there. Same thing with like tea. Like if you want to dilute your tea, you're not taking any of the tea out. You're just adding more water and diluting it. So it will not change. And the more dilute the solution, think about it, the more dilute, so you're making Kool-Aid and you add tons and tons of water, what happens to the color and the taste? It's less. The less intense the color and the taste. I'll fix all the words for y'all. Hopefully all you have are the right words up there. The opposite of dilution is to concentrate. That one's in there. A solution. Solvent is removed. If you're trying to concentrate something, you remove the solvent to decrease the volume, and it decreases the denominator. So by the way, this is evaporation, like you're evaporating some of it. And on Newton, you're going to see 2 formulas. These are the 2 formulas you're going to be using today. You got this one and this one. I prefer this one. I saw this one in OpenStax, but also I saw this one on Newton. C stands for concentration, and molarity is a type of concentration. So that's why there's sometimes a C, and then this is molarity. So the 1 refers to the concentration and volume of the concentrated solution. Concentrated. And the 2 refers to the concentration and volume of the dilute. Now, honestly, I switch these all the time. You're still going to get the same numbers. So just make sure you have the molarity and the volume of the concentrated like on the same side. That's the key part. Notice this though, both volumes should have the same units. You shouldn't have to convert them to any particular volume unit. And if you skip to the 7.02 on this video, it looks like this. He shows how to do a dilution. You're gonna have to skip past the video thing there, but skip to that part. If you want to see a dilution in lab, it's like 3.5 minutes, I think is what it is. Little pro tip, how to tell if it is a dilution problem, because this is our other equation. So notice earlier we had all the molarity where we just figured out molarity. So this is one type of problem, and then this over here, this is the second type of problem. Okay, so what we're talking about, this is the second time. So how to tell dilution and not just solve for molarity. So dilutions will need at least 3 pieces of information, because notice with the equation you've got 1, 2, 3, 4 things, so you need to know 3 of them to solve for the last one. And notice 2 of them will have the same kind of unit. You'll either have like 2 liters or like 2 volume units and 2 molarity units. They're also going to have the words like either dilute or concentrate and something like making a new solution or added to, kind of things like that. In both types, the word of is used to tie numbers together. I'll really try to emphasize that in this part. And to indicate multiply, you'll see that we do multiply things that are of'd. In regular molarity, we'll usually only have 2 pieces. Oh, and that's not including molar mass, because you got to have that. Sometimes molarity does give you more information than 2 pieces. I'm just reminding you, you only need to convert to moles and to liters for molarity. So example problem. This is what I do with these. So we have this volume. So I know it's volume because it's a milliliter. So volume, and I'm just going to say 1 because I'm starting the problem. See how we have this of word? It ties those guys together. That's our molarity, 35 of this kind of molarity. See the is diluted to word right there. New volume, again, it's dilution. And then here's volume 2. Do a quick check. Are my units the same? Yes? Okay, I'm good. What should the molar concentration be? So again, we just are plugging in the numbers. So here's our molarity. And then here's our volume there. And then this is the other volume on that side. You're going to divide both sides by 100. That's how we got to this next step. So we divided both sides by 100. And then when you put it in, your milliliters cancel and you're left with molarity. That's your new dilution. Notice you started with something concentrated and it became less concentrated. That's the point. But sometimes you'll start with something dilute and they'll have you go concentrated. But I'm just saying the point is that it changed.